Hey everyone, welcome back to our statistics class notes. This is the last video and the last material for our introductory statistics course here at Flagler College. And we're on page 151. And I just wanted to remind you that we have about one and two-sided alternative hypotheses and what the p-value is in these situations. And just as with hypothesis tests for proportions, hypothesis tests for one-sided or two-sided can be one-sided or two-sided depending on the research question. So the choice of the alternative hypothesis determines how the p-value is calculated, of course. Now again, we're not pulling from the normal distribution, although they look very normal. There's more area in the tails, though, than the normal distribution has. Okay, so always are null no matter what type of hypothesis test, whether it's two-sided or one-sided. The null hypothesis is always that we're assuming the population mean is equal to some known value from past information. So mu is equal to mu naught. Now, if we want to test alternatively that it's not that, it's changed, it's different, etc., those are keywords that we see, we're looking at a two-tailed test. So depending, we could get X bar here or we could get it over here, but the bottom line is whichever side we get X bar on, we didn't care if it was less than or greater than. We need to look at the area in the tail from that test statistic to one more extreme and then multiply that times 2 because the area in the other tail as well. So the p-value is probably that t is greater than that t stat if I change X bar to a t statistic, which is what we have done. Remember, the t stat is X bar minus mu naught over the standard error estimate. Plus its probability is less than or equal to minus t stat if t stat was over here, or vice versa. If I have a one-sided left, I'm just trying to see if the population mean has decreased, gone down, etc. Then I'm looking on this side, the p-value is just the area in this tail. So that's the probability that the t is less than or equal to t stat, the one that we get. And if I have a one-sided right where I'm trying to test alternatively that the population mean is greater than what we knew from the past, then the p-value is just the area in that tail. And again, these are all from the t-distribution technically, which is not the normal, but looks very similar to the normal. Okay, so recall that the p-value is the probability of getting the test statistic that we obtained, or one more extreme. In other words, it's the area in the tail, or tails, if it's a two-sided test. And let's do one last example. In 2010 season, average home attendance for NHL hockey games was 17,702. So this is what we know from past information. That's our mu naught. Suppose a sports statistician took a random sample of 30, so our sample size is n of 30, home hockey games during the 2014 season and found a sample mean of 18,104. So what we'd like to know, if that sample mean is enough information to say that, can we conclude that the mean attendance at NHL games has changed? So we're looking for a two-sided hypothesis. And we also have information that the sample standard deviation, S, is 1,203.5. So the hypotheses are, the null is that mu is equal to 17,702, what we knew from the past. And the alternative, what we hope our sample can statistically demonstrate for us, is that it's not equal to that anymore. It's changed. Again, in the preparation phase, we have to look at the sample and see if it's random and independent, and we have to make sure our sample is large enough. So as long as it's more than 25, or at least 25, we're good. If the population were normal, we wouldn't have to worry about that, but we don't know about the population, so we need a sample size of at least 25. And we need to choose a level of significance. One was not given to us in the problem statement, so let's choose the common typical alpha of 0.05. And we'll use StatCrunch. So remember, I use t-stat, one sample with summary. So I'm not going to pull that up for you this time, but I got to put in the sample mean, the sample standard deviation, and the sample size. Make sure I check that I'm doing a hypothesis test and put in my hypotheses that I want. And here's my results. I get a really large test statistic and I get a really small p-value. So since the p-value is really small, less than 0.0001, which is less than alpha, right? Since the p-value is less than alpha, we reject HO. Thus, there is sufficient evidence to support the alternative. That is, the mean attendance at NHL games changed between 2010 and 2014. And congratulations, everybody. You have finished doing the notes for your statistics course here at Flagler College.